Welcome to G Fun Facts Online. When we hear the word geometry, most of us immediately picture a dusty chalkboard, a compass, and the ancient Greeks. We think of Euclid proving theorems or the massive pyramids rising from the sands of Egypt. We tend to view mathematics as a late invention of civilization, something that arrived only after we learned to write and build cities. But the truth is much older and far more fascinating. Geometry did not begin with the first written equation. Long before the pyramids, long before agriculture, and even long before our species had fully conquered the globe, our Stone Age ancestors were already thinking in shapes, patterns, and symmetries. Today, we are going to trace the hidden origins of geometry. We are going to explore how the human mind first grasped the concepts of form, space, and measurement in the deep past. We will travel from the deliberate chipping of a hand axe 1.7 million years ago to the precise layout of megalithic circles, proving that prehistoric humans were laying the cognitive foundations for mathematics long before history began. The story of geometry begins not on paper, but in stone. For over 1 million years, the primary way humans interacted with geometric concepts was through lithic reduction, which is the technical term for making stone tools. This brings us to our first major milestone, the Acheulean hand axe. Around 1.7 million years ago, Homo erectus began crafting these specific tools. Unlike the rougher, opportunistic tools that came before, Acheulean hand axes were teardrop-shaped and bifacial, meaning they were flaked on both sides. But what is truly remarkable about them is their bilateral symmetry. To create a symmetrical object from a rough, irregular nodule of flint requires a massive cognitive leap. It requires a mental template. The maker cannot just chip away randomly. They must visualize the finished three-dimensional shape within the stone before striking a single blow. This ability to rotate an object mentally and impose a geometric plan on raw material is one of the earliest evidences of advanced spatial cognition in the fossil record. Anthropologists have noted that many of these hand axes are actually over-engineered. They are symmetrical to a degree that exceeds functional necessity. While symmetry certainly helps with aerodynamics and handling, the precision found in some of these tools suggests an early aesthetic preference for geometric regularity. It was a precursor to the philosophical concept of ideal forms, manifesting in the hands of our ancestors nearly 2 million years ago. Jumping forward significantly in time, to around 13,000 years ago in North America, we find the Clovis people taking this embodied geometry to new heights. The Clovis projectile points are masterpieces of craftsmanship. They are lanceolate or leaf-shaped, with parallel or slightly convex sides and a distinct concave base. Recent scientific analysis using three-dimensional geometric morphometrics has revealed something astounding. Clovis points, found thousands of miles apart, share an incredible consistency in their proportions. This implies a standardized system of measurement or a highly rigid cultural transmission of geometric ratios. It was, in essence, an unwritten engineering standard maintained across a vast continent, demonstrating a sophisticated understanding of shape and consistency. While tools showed us implicit geometry, cave art reveals the birth of explicit geometric thought. When we think of cave paintings, we usually think of the famous bulls and horses of Lascaux or Chauvet, but alongside these animals are thousands of abstract signs: dots, grids, zigzags, and nested curves. In 2002, archaeologists in South Africa made a stunning discovery at Blombos Cave that rewrote the timeline of abstract art. They found pieces of ochre, a soft, iron-rich stone, engraved with a cross-hatch design bounded by parallel lines. These engravings are approximately 73,000 to 100,000 years old. This is significant because it is not a random doodle. It is a deliberate, repetitive, geometric pattern. It suggests that early Homo sapiens were capable of abstract representation, using a symbol to stand for an idea, long before the famous European cave paintings. The crosshatch is a foundational geometric grid, arguably the earliest evidence of a drawing that represents a concept rather than a creature. But why do we find the same geometric shapes like spirals, grids, and zigzags in prehistoric rock art all over the world, from Ireland to Australia? Archaeologists David Lewis Williams and Thomas Dowson proposed the neurovisual resonance theory to explain this global consistency. They argue that these shapes are form constants or entoptic phenomena. These are visual effects generated by the human nervous system itself during altered states of consciousness, such as trance, sensory deprivation, or ritual dance. In the first stage of a trance, the brain literally sees geometric patterns. Paleolithic shamans may have projected these internal visions onto cave walls. Thus, the earliest geometry might have been an attempt to map the architecture of the human visual cortex itself, making the subjective objective. As we move into the Neolithic Revolution, when humans settled down to farm, their relationship with geometry changed again. They needed to measure fields, build permanent houses, and track the seasons. This led to the first monumental geometry. The most game-changing discovery in this field comes from Göbekli Tepe in southeastern Turkey. This site is 11,500 years old, built by hunter-gatherers, not farmers. It features massive T-shaped pillars arranged in circles. In 2020, Israeli archaeologists Gil Huckley and Avi Gopher used algorithms to analyze the layout of the site's 3 oldest enclosures. They discovered that the center points of these enclosures form a nearly perfect equilateral triangle. This implies that the builders did not just place stones randomly, they had a master plan. Laying out an equilateral triangle on this scale requires an understanding of basic geometric relationships and likely the use of ropes or measuring cords. This was happening thousands of years before the invention of the wheel or writing. Moving to Western Europe, we see similar sophistication in stone circles, like Stonehenge and the Karnak stones. Researchers have long debated whether these builders knew the Pythagorean theorem millennia before Pythagoras. Some stone circles, like the Crocuno rectangle in Brittany, form precise 3-4-5 right triangles. Engineer Alexander Thom analyzed hundreds of stone circles and proposed they were built using a standard unit he called the megalithic yard, which is exactly 2.72 feet or 0.829 meters. While his theory is controversial, his work showed that many so-called circles are actually complex shapes, like flattened circles or egg shapes. These shapes require multiple center points and varying radii to construct, which is a clear sign of compass and rope geometry. Further north, in the Neolithic village of Skara Brae in Scotland, inhabitants carved mysterious stone balls that continue to puzzle archaeologists. Many of these balls are carved with knobs or discs, arranged in perfect symmetry. Some of them resemble Platonic solids, such as the regular tetrahedron or dodecahedron. While we do not know if they were weapons, status symbols, or games, their manufacture demonstrates a fascination with dividing a sphere into equal, symmetrical sections. This is a complex three-dimensional geometry problem that these Neolithic craftsmen solved with stone tools. It is crucial to recognize that this geometric impulse was not limited to Europe or the Near East. It was a universal human trait. In the Americas, the Corral Supe civilization in Peru, which is the oldest civilization in the Americas dating back to 3000 BCE, built massive sunken circular plazas and pyramidal mounds. The precise circularity and cardinal alignment of these structures indicate a strong grasp of radial geometry and astronomy. In Argentina, at the Cueva de las Manos, alongside handprints that are over 9,000 years old, we find distinct geometric sets. These include zigzag patterns and dots that may represent clan markers or astronomical events. In Ecuador, the Valdivia culture produced some of the earliest pottery in the Americas, featuring intricate incised geometric motifs that play with symmetry and repetition. In Oceania, the Lapita people, who were the great explorers of the Pacific around 1600 BCE, are famous for their pottery decorated with dentate stamping. Anthropologists analyzing these complex, interlocking patterns have found that they strictly follow specific rules of symmetry operations, including translation, reflection, and rotation. These are the same rules used in modern group theory to classify patterns. In Neolithic China, the Hongshan culture created ritual jades, like the Bai disc, representing heaven, and the Kong tube, representing earth. The precision of these perfect circles and squares, ground from extremely hard jade without metal tools, is a triumph of prehistoric engineering. Finally, we must ask, how did we get from this artistic and architectural geometry to the mathematical geometry we use today? The bridge might lie in humble clay objects found in the Near East. Danish Schmant Besserat discovered that, before writing, people used small clay tokens to count goods. These tokens came in specific geometric forms. A cone represented a small measure of grain. A sphere represented a large measure of grain. An ovoid stood for a jar of oil, and a disc represented a sheep. This system was revolutionary because it separated the quantity from the object. A cone wasn't just a shape, it was a standardized unit. Over thousands of years, these three-dimensional geometric shapes were impressed onto clay tablets, evolving into two-dimensional circles and wedges, which became the first written numbers. Thus, the cone and the sphere are the direct ancestors of our written numbers 1 and 10. Tracing geometry in the Stone Age reveals that mathematics is not an invention of the classroom, but an innate capability of the human mind. It started as an embodied skill in the symmetry of the hand axe. It became symbolic in the ochre grids of Blombos. It became architectural in the triangles of Göbekli Tepe and the circles of Stonehenge. And finally, it became abstract in the counting tokens of the Near East. When we look at a skyscraper or a microchip today, we are using the same cognitive tools that our ancestors used to navigate the stars and shape the stone. We are, and always have been, a species of geometers. Thanks for listening to G Fun Facts Online.